Hello, this is Todd Flanders. I want to take you through a kata for doing legacy code rescue. This is a popular kata, Gilded Rose. Emily Bosch has the official well-maintained site, so we will be cloning her version of this. For tools, we're going to be using approval tests, which will allow us to quickly record multiple combinations of input data and characterize the expected outputs, which will allow us to begin our refactoring efforts quickly without having to handwrite a bunch of characterization tasks. This project says it's not actively maintained and to consider using this other library. However, we are seeing active maintenance here, and the new library does not appear to have the combination approvals functionality that we will be using. So things may be changing in the future, but for now, let's go with approval tests. The other tool that we will be using is Striker Mutator, which is available in multiple languages. We're going to be using striker.net for a C# project of Gilded Rose. And the idea of Striker is that it will mutate your code to see if there are any mutations that survive your test suite, meaning that any mutation of the production code should result in a red test. So we will be using Striker to evaluate the quality of our approvals test as we move forward. So let's start by cloning Emily's repository. So I'm going to grab the HTTPS URL, pop over to Windows, get clone, paste. There we go. Okay, so far so good. Let's see if we can load that project. So I'm going to fire up Rider. You can use Visual Studio or Visual Studio Code or whatever IDE is your favorite. Being a .NET Core project, it's pretty easy even without an IDE. Okay, so open. Yep, I've got this in my Gilded Rose, in my C# folder. This is exactly what I want to have, so I'm going to open that. Pause a little bit while we load. Okay, great. Now my project is loaded. I have some problems. I see in the status bar here that it's targeting Net 6, which I don't have. I'm going to target Net 5, so let me do that really quick. So we'll go into the properties of the project. Net 6 is selected, but I don't have that, so I'm going to select what I do have. Okay, and I have two projects. I have a test project and a production code project, so I'm going to have to do that in both. So go on the other project, select Net 5. Okay, let's do a build. That's good. We're going to ignore this test text fixture and just use this Gilded Rose test. So we bring up that test. Okay, discover please. Thank you. Run. This test is poor quality for multiple reasons, so we're going to fix that. We actually have an assert failure that we're creating an item with the name of foo. We run through our system under test, and we want to assert that the name has been changed to fix me, which isn't what the actual code does. It doesn't mutate the name. So we're going to change this back to foo, change the name back to foo, and rerun the test. Okay, very good. So now we have one low quality test that has a really bad name that is going to verify that the name of of an item does not change when we run it through the update quality method, whatever that does. Okay, we definitely are going to want to do better. Let's try to use Striker to see how bad this test really is. So I'm going to pop to a terminal window, and I'm going to refer to the Striker documentation on getting started. So it recommends that I install Striker as a global .NET tool, which is a really good idea because that allows you to use Striker on any project, not just projects that have Striker installed in its tool manifest. So we're going to go ahead and create the tool manifest so that any future developer that pulls this project who doesn't have Striker can simply do a .NET tool restore, install Striker for the project, and have the Striker functionality available. So I'm going to copy this method, copy this command. Oh, and by the way, it says install in the project. So that's going to be our test project. So the first thing I'm going to have to do is navigate to our test project. We have two of them. We have GildedRose tests. We want to go to GildedRose tests, and now I can paste my .NET Tool manifest. So at this point, very good. I've got a .config folder that has a .NET Tools JSON. So now I'm going to take a look at that. Cat config / .NET Tools JSON. So it's basically an empty file. So at this point I'm going to run my next command, which is .NET Tool install .NET Striker. So paste that in. Very good. It says I'm good to go. I'm going to look at that JSON tools, and it says that Striker is one of my tools. This is good. This is a commit-worthy change, so I am going to create a new branch for my commits, and I certainly don't want to push to Emily's repository. I'm sure she's locked people out from it anyway. So I'll get checkout -b Todd /solution. Seems to be a pretty decent name. Okay, cool. So there's all my changes. Git add -a because I am in a subfolder and I want to make sure I catch this CS proj. So I'm going to commit -m downgrade to net5 and configure Striker. Okay, cool. So now that I've done that, I should be able to run Striker. So I will do so by doing a .NET Striker command. And I'm also going to add the -o option because I want the Striker output, assuming this runs, to pop up in a new browser window. Okay, so it's going to try to identify the project to mutate. It's going to mutate GildedRose. That's my production code. That's exactly what I want. It's going to go against the current project, which is GildedRose tests, which is exactly what I want. It found one test, which is what I expect. Created 78 mutants. Skipped 45 of them because of lack of coverage. Okay, so that's our first smell, is that we have low code coverage. But even with high code coverage, it's possible that we are running through code but not asserting the results. So Striker will both check us on our code coverage and also the quality of our assertions. So again, all we're asserting is that the item name does not change. So, okay, very good. So we've got our report. Our score is 3.85. We would like to target 100%. We might not get there, and that's okay. So let's see what we got. So we see that 3 mutations were actually killed. 30 mutations survived and 45 mutations weren't even run because Stryker knew that there was no code coverage. Yeah, we see this loop, the equality mutation survived, and we're seeing a lot of stuff with this aged debris and backstage passes. We can open up some of them for fun. So it changed the or to an and. That didn't cause a red test. What did it do here? It negated the condition. That survived. And we can expect that because we don't have anything in our test that has anything to do with aged debris or backstage passes. Okay, what's this one? Not equals was changed to equals. They blanked out the string age debris. Backstage passes, not equals became equals. Okay, and again blanked out the backstage passes. So let's set a goal to get some code coverage on these names. This is a very low goal, so it should be able to resolve that pretty quick. But first, we need to set up the combination, the approvals testing. So I'm just going to make a note in my test, paste that in as a comment. Very good. All right, now we want to set up approvals testing. So that is going to be a NuGet package. So I'm going to go over to NuGet, search for approvals. And there it is. And it's not installed in either project. It's a testing utility, so it only needs to be in my test project. I don't need it for production code. So I'm going to go ahead and do an install. All right, so as it was successfully installed, I'm going to start a brand new test that's going to eventually replace this original test completely. And I'm going to call it public void approval test. Okay, that's just going to be empty for now. I'm going to pop over to the documentation. Okay, let's figure this out. It's a little bit of a Rube Goldberg machine to find the docs for the combination tests. So here I am at the approvaltest.net main page. I'm going to drill into the docs folder, drill into approval tests, and then there's a link to the verify functions. And inside that, I should be able to find verify all combinations. Here we go. All right. So basically what I'm going to do is take a function and then also a bunch of lists of parameters. Okay. So let me go back to our code. Combination approvals dot verify all combinations. All right, cool. So the first thing I'm going to need is a lambda. So I'm going to make that an explicit named function called test GildedRose. Okay, and that's a lambda, so I'm not going to actually call the method. I'm just going to refer to it, and it doesn't exist, so it's red. And then I'm going to need some sample data. So for now, I'll just have one thing. I'm going to make a new list of strings. And I will just initialize that list with one parameter called foo. Okay, cool. So now I'm going to need this here lambda. So I'm going to try create method. Yes. All right, cool. So I got a method that takes in a string argument and returns an object, and it throws. I think I have enough to be able to run this test, so let's do it. Obviously not, it's not a useful test at this point. Okay, great. I get this nice welcome to approval test. It says I need to annotate my class test method or assembly. I would normally do it on the class, but just for fun, I'm going to do it on the test. Okay, I need some imports. And let it happen again. Okay, this is very interesting. So now, instead of just getting I'm going to leave this process still running. Instead of just getting a red or a green, I actually got a red that I don't have approved results. So this is the approvals window. It's actually bringing up the tortoise compare on my computer, but on yours it might bring up a different compare utility. So on the left-hand side, it has the actual behavior, and on the right-hand side, it has the behavior that I approved, which is empty because I haven't approved any behavior. So the behavior we're seeing on the left-hand side is the input parameters, then the equal greater hash rocket, and on the right-hand side, we have the actual output, which in this case is a exception message. So if I like this behavior, I can move the received over to the approved, save the file, run again, and I'll get a green test. I'm going to go ahead and do that even though this is really a bad thing to approve, just so that you can see the green test. Very good. So now I have a green test. So long as neither the behavior of my test nor the behavior of my code changes, this test will continue to run green. But obviously this test is not sufficient for our use, so I am going to make the test red by enhancing the test suite. So here we go. So for testing GildedRose, I'm going to need 3 pieces of data for a particular item that which I want to update the quality. And that's going to be the item name, the sell-in, and the quality. So I am going to make those as named lists rather than the anonymous list that I did here, because I think that works better to document your tests as an executable specification. Okay, so I'm going to make a variable called name sample names. And that's going to be equal to a new list of strings. And I'm just going to pass in a pop in 3 since we've already ran Striker and found that we want to do the age brie and the concert tickets. So I'm going to have a normal item. I'm also going to have aged brie. Note that I didn't bother to read the README to see what this program is actually supposed to do, because I don't really care what it's supposed to do. I only care about what it actually does. And this is a concept that's going to run counter to a lot of our sensibilities, because we have a strong desire to know what we're doing. But in this case, we only care to know what the code is doing. Our desire to know what we're doing is going to increase as we characterize and clean the code. Okay, so I've got 3 sample names. I need some sample sell-ins and sample qualities. The only ones they give us are 0 in the original test, so I'm just going to preserve those. Sample sell-ins. So it's going to be a new list of integers. And I'm just going to pass in 0. I don't need these bow legs for that initialization, so I'm going to get rid of them. And then I've got the same thing for the sample qualities. Okay, cool. All right, so now my GildedRose tests. I am going to go. I'm going to go vertical. So now instead of passing in this new list of foo, I'm going to pass in my sample names, my sample sell-ins, and my sample qualities. Okay, and that goes red because this function is right now only taking a single string. So I'm going to take in, the first arg is going to be the item name. Second arg is going to be the sell-in, which is an integer. And the third is going to be the quality, which is also an integer. Whoops, lowercase q. Okay. And that allows us to go green in terms of the compiler. So let's run it from the test perspective, and we expect red because now we're getting new combinations tested. And indeed we do. So we have normal item with a, okay, leave running. We have a normal item with a quality of 0, selling of 0, age breed also 0, 0, and backstage passes 0, 0, and nothing is implemented. So this is a really bad test. So this time I'm not going to bother approving it because I still don't like the results. I don't like the method or operation is not implemented, so let's fix that. Okay. The easy fix is just to delete it, so let's do that just for fun. No, let's return null. Okay, going very slow here because things that we learn slow, we forget slow. Okay, so now instead of getting the method is not implemented, we just get empty output because we're returning null, which makes sense, but it's not what we want. So let's not approve that one either. So what I actually want to do is call my system under test here, and I've got an example right here with these 3 lines of code. So I'm going to copy and paste those. Okay. So what I really want to return is the item that I mutated. So I'm going to return, and we're mutating this list in place. I know this because I've done this kata many times. Otherwise, we might have to spend some time figuring out what we actually want to do here. I'm just going to bypass that analysis and we're going to return item 0. Okay, so, but I want to use my input parameters. So my name is going to be my item name, which I messed up. I'm going to have to refactor and put that in the proper case. And I'm going to want to use the selling and the quality. Pass it down the command line. Very good. Okay. I'm going to var this GildedRose app just for a little clarity. Let's run this. Okay, so now I output the item, and the test will tell me the item class name, which is GildedRose Kata.item. That is also not useful, so I'm not going to prove this test. So now I'm at a crossroads. 2 things I can do is I can either put a toString method on my item so that when I return items.0 and then the approvals framework does a toString on it, I get nice output. Or I can simply roll my own test reporter in this app, so in this test suite. So that's what I'm going to do. I'm going to roll my own. So instead of returning item 0, I'm going to return a report that I'm going to build. And I'm just going to quick and dirty use string interpolation to build this report. So I'm going to take item 0 dot quality, comma, item sub 0 dot selling, squiggly comma squiggly, item 0 dot quality is the next one. Okay, cool. And all right, that looks like that should work. Run my test. All right, nice. So I see for normal item, wait a minute, what did I do? I did something stupid. Yeah, let's do items 1 name, not quality. All right, one more time. Okay, so we see that the names don't change for any of them. The The selling went from 0 to -1, and the quality for brie went to 2, but the quality for the other ones are 0. Okay, that means something. Let's approve this because that seems like a reasonable test, reasonable behavior, given that we don't understand the code. But again, what we're doing is we're characterizing exactly what the code does. So I move it to the right-hand side, save, run the test again, and I see green. So at this point, let's run Striker again and see how this test has affected our quality, our test quality, now that we've added backstage passage and aged brie. So I'm going to pop to my terminal and rerun this test. And here we go. It looks like now we only have 10 means of status no coverage. I think that was in the 40s the last time. So it looks like we're moving forward, even though we've actually done very little in terms of characterizing our test inputs. Okay, yeah, our mutation score increased significantly. I have my old report here up in the other tab. So we can see we went from 3.85 up to 48. So let's see what happens. Okay, so we have a green here. We have some mutations killed for backstage passes, but not all of them. Okay, so it looks like we are moving forward in a good direction. We see another name here. So this isn't even covered at all. So the mutations were skipped. So let's characterize this bit next, sulfurous. And by characterizing it, I mean all we're going to do is paste that name in to our test. So we're going to go here. And grab this string, pop it in. Now we're getting kind of long, so I'm going to go vertical on these names. Normal item age brie, backstage passes, and sulfurous. Okay. So let's look, see if there's any other name strings that we want to grab. I don't see any, so let's go back to our test. And now we've changed the test. Let's see what shade of red that is. Unit tests. Here we go. Okay, so that gave us one brand new test, which seems very reasonable. So we're going to prove that. Okay, cool. Let's verify that we're back to green and then go through the striker mutation again. This is going to be kind of a wash, rinse, repeat effort here until we like our striker report. Okay, this is slightly better. Okay, so here we have equality mutation survived because we are comparing with quality. So apparently if we test with quality greater than 0 or less than 0, it doesn't matter. We have some kind of boundary condition with quality at 0. And looking forward, I see we have another one with quality of 50. But let's take the 0 case first. So we have 0 already in our test samples for qualities. Well, let's see what happens when we get values on either side. So I'm going to do -1, 0, and +1. So now I'm catching the boundary and the smallest increment on either side of the boundary. Pretty typical thing that you will do with TDD is this kind of boundary testing. Okay, so I've added new test data, so I'm going to expect red because I have new values that I need to approve. I feel like I can get rid of that original food test now because that provides no value. A normal item Quality stays at -1, stays at 0, and goes from 1 to 0. With Brie, quality goes from -1 to 1, from 0 to 2, and from 1 to 3. For the tickets, quality goes from -1 to 0, which is interesting because that's different from the normal item. When it is at +1, it goes to 0. Sulfurous, quality doesn't change. Let's prove all those results because, again, this is what the code does. I don't have to make a value judgment of these results, but it is kind of nice to see the patterns just to try to get some understanding, but it's absolutely not necessary. Okay, I'm going to run to go to green, and I hate this original food test, so it is going to die. And now I only have an approval test, which allows me to move my reporter to the class level. So I'm going to go ahead and do that because that's my normal practice. I expect to still be green because this refactor did not change test behavior, and indeed I am. So let's see what the impact of that quality boundary test for the value 0 actually did. Okay, it doesn't look much different. 5769. What was it before? 5123. Okay, so now we don't have any dots on this quality, so I think we're good. But we do have that the block removal survived. Okay, why would that block removal survive? Oh! So if I don't do anything to sulfurous, that's a big clue for how we want to refactor this code. But yeah, let's take a look at this other dot of survive mutation for the quality at the boundary of 50, because that's a really easy thing to do. So let's do that. So now for qualities, we have, let's do 49 to catch the upper end of the lower boundary, 50 to do the boundary itself, and 51 for the lowest value of the upper boundary. And at this point, you know the program, run the tests, look at results, approve them. Okay, very good. So we see age Brie went up to 51. And normal items just decreased by 1. Backstage passes all stayed at 0. As we expected, sulfurous never changes. So very good. So let's approve this. So even though we're not concerned with understanding the production code behavior, we're actually gaining some of that knowledge through this process. Good. Let's mutate this and see what happens. Okay, I should still have the same number of mutants every time. This progress bar is showing what mutant we're on, how many mutants were killed. We ideally would like to see all of our mutants killed, mutants that survived, and mutants that timed out. We haven't experienced any timeouts, but some mutations will result in things like infinite loops. Those mutations will just need to be killed. But if a mutation results in an infinite loop, that's actually a good thing because that means that your test is failing by hanging. Hey, we're in the yellow now. That's very good. So our score increased significantly at this point. Okay, we still have this red here. So, but we see our quality went completely green. We're actually not. I suppose if I clicked on this killed, yeah, it'll show a bunch of killed mutations, which is really good. So let's keep going. So I'm seeing more boundaries here. This for Selin, we have a boundary of 11. So let's add that to our test suite. So for sample Selins, we already have 0. So we want 11 and we want 10, the upper value of the lower boundary and the lower value of the upper boundary. So we get 10, 11, and 12. Let's take a look at the code here. We've got another one for 6. So we'll do the same thing for 6 that we did with 11. So back to the code. So we're going to want to test 5, 6, and 7. Okay. Run tests. Many more permutations of outputs. Okay. This looks pretty interesting, but it's too much for me to read right now, so I'm just going to prove it and go forward. But now what I have is a file that allows me to look at what kind of features, what kind of relationships there are between input data and output data, which gives me a clue of what features the actual production code has. And again, I could look at the README, but I don't trust documentation when it comes to legacy code refactor, because what's important is not what the code should do or what people think the code does. What's important is what the code actually does. Mutate again. Holy cow, we are looking really good right now. We only have 2 survived mutations. Selin less than 0. That's an easy one. Okay, something I should have pointed out earlier as we went through these mutations is that initially we had quite a bit of not covered code, and after that went down for our second refactor and was completely eliminated with the last one that we did. So even though we've got 100% code coverage, our mutation score is not 100% because just because we're exercising code doesn't mean that we're asserting the behavior. So the idea of this mutation exercise is to verify that the functionality of the code is actually asserted in our tests. And we're not simply relying on code coverage, which can be a dishonest or overstated metric for our test quality. Okay, so here we go. And again, Selin, we have a less than 0 boundary, so let's capture that in our test suite. So I just simply have to pop it to -1 here. And go. Run the test. Okay, so I'm going to go ahead and approve everything. Yeah, I've got a bunch of blocks here for every type, so for every item name. Approve them all. So I have quite a large sample of permutations, 192 of them. So that's a pretty good representation of what the code actually does. And the mutation is hopefully going to go up to a really high number now. Let's see what it actually is. And 8.72. 1 mutation survived. This is very interesting. So we do have Selin at -1. Well, certainly that's going to fail. We have Selin 0. Why wouldn't we get a different behavior at 0 and let me make sure I didn't do something dumb with my test examples. Sample Selins. Oh, I don't have 1 in here. There's my problem. All right, cool. The universe makes sense, which is always a wonderful thing. It would always make sense if we understood everything all the time. How's that for a profound statement? Okay, let's prove that. I'm gonna kill this. Hopefully I did that right. Let me run, make sure it's green. And I did, good. Yay me. Alright, one more time. Last mutation. %. How you like that? So at this point, we can safely refactor and even completely bulldoze the production code and rewrite it. But we're going to refactor it piecemeal because that is safer and, in my mind, a little bit easier because I don't have to think about design up front. I can allow the design to emerge as I refactor.